Okay, Chapter 7, Lesson 6 is transformations of exponential functions. So these notes we have discussed now about 3 times. We put these on the brown part of our notebook for quick finding. So we're just going to run through them quick. Originally it came from lesson 3.5. So any negative sign out front will flip our exponential function. If the negative sign is in the exponent, reflects. So if we have like a negative and then x to the second. So originally our x to the second would look like this. And if we do the negative out front, what it's going to do is flip it this way from growth to decay. However, if we have a negative in the exponent like this, it's going to take our original one and it's going to flip it upside down. So it actually could have 2 flips. It could flip like left to right and then also flip up down. Any number inside the grouping symbols with x moves it left or right. However, it's opposite the sign, remember. A number added to the end is up or down. And a number multiplied out front is called dilation. That's our slope. So here they're giving us an original function and they want us to write another one. So they want us to take 4.6x plus 2 and move it up another 5 units. So I'm going to add that to the back to make it go up. And so my new one will stay as 4.6 to the x power. However, when I combine like terms, it'll be plus 7. On number 2 now, they want us to move it down. So I'm going to put a minus 2 at the end. So my g of x would become 0.5 to the x power minus 2. If I want to go 3 right, I have to think opposite. And I also need a set of parentheses to do that with the x. So I would do x minus 3 in parentheses. If I want to go 1 unit left, again, I have to think opposites. So I need a parenthesis with x plus 1. Compressed vertically is the same thing as stretched horizontally, horizontal stretch. That's how we're doing it here with Mr. Reader and I. So I'm going to have g of x equals 1/4 out front times 6 to the x power. And the last one, if I want to stretch it vertically, I'm going to put the times 3 out front and then 2 to the x power. So now we have kind of the same thing except for we are giving the move. So this one is a little hard because the 3 is still technically in front of the x. And remember, it goes y equals mx plus b. So even though it's not out front of the equation, it's up in the exponent, and it still does the same thing. And so this would actually give us a vertical stretch. On this next one, the change was a 0.4 added. So that would be something that's between 0 and 1. So that would be a horizontal stretch. On this one, the change was that a negative sign was out front, so that would be a flipped. On this one, they added negative and a horizontal stretch out front. On the next one, they put a negative in the exponent. So here's where we have our reflect one. On this one, we have a reflect because of the negative in the exponent, and we also have a down 10. On this one, we have a negative out front, which is our flip, and we have a plus 2 in our exponent, which is actually left 2. In this last one, we have a reflect, and it started at negative 1, and now it's all the way to a plus 8, so that's actually a shift of 9. Now, we can look at like all of these in our calculator. So if I pull that up real quick, if we look at that 5 to the x and then 5 to the 3x power. So I'm going to put 5 to the x power in my y. Turn my plot off real quick. In my y1. And then 5 to the 3x and my y2. So it looks like this. And then graph those to see the change. So the blue one is there. And then when you see the red one, you notice that it's more vertically stretched. So same thing if I look here at 2 to the x power minus 5 as my original, and 2 to the 0.4x minus 5. Looks like this. And when I graph it, there's the original, and there's the more horizontally stretched one. So you can look at all of these in your calculator to double check what you are writing down as your thing. So let's look at one of these reflect ones. So we have 5.2 to the x for my original, and 5.2 to the negative x as my second. So it should look like this. And then here's the graph of the first one. And then the second one will reflect. And so it's just reflected instead of a growth, now it is a decay. And then if we would put the negative out front for the flip, so if I had negative 5.2x, so if it looked like this, then my first one would look like that blue still. And then when I flip it, it goes upside down, so it would look like that.